Hello students, I am Sangesh Kotti and you are watching Effortless Chemistry, and our today's topic is how to find the shape of the molecule. Finding the shape of molecule in chemistry, it is very important, because once you know the shape of the molecule, you can readily predict the angle between the two bonds, or you can predict the dipole moment of the molecule, and directly you can calculate hybridization of the molecule based on the total number of bond pairs and lone pairs present in the molecule. So finding the shape of the molecule is so important in chemistry. In today's video, I am going to explain you a simple trick to calculate the total number of bond pair of electrons and lone pair of electrons, how to find the shape of the molecule, and what is the difference between the geometry of molecule and shape of the molecule, and what are regular shape molecule and irregular shape molecule, and what is their relation with the dipole moment. All these questions will be answered in this video, so watch the video till end. Let's get started. Now the shape of the molecule is explained by using VSEPR theory. This VSEPR theory is nothing but valence shell electron pair repulsion theory. By using this theory, we will predict the shape of the different molecules here. According to this theory, the first point is the shape of the molecule depends upon total number of bond pairs and lone pair of electrons present in the valence shell of the central atom. So that according to this point, first you have to find out which is the central atom in the molecule, then you have to calculate the total number of bond pair and lone pair of electrons, because the shape of the molecule depends on what? The total number of bond pairs and lone pair of electrons. Here is the trick to calculate the total number of bond pairs and lone pair of electrons in the molecule. The simple trick for this one is, I will take an example. This is a very simple example. I will take first one, CH4 molecule. Any molecule is given to you. First you have to identify the central atom of the molecule. Then you write the number of valence electrons present in the central atom. In this molecule, carbon is the central atom, which is having 4 valence electron. Out of 4 valence electron, one electron is used for the bond formation with the hydrogen. In total, how many bonds are formed here? 4 bonds are formed. That's why this molecule is having 4 bond pairs. You can write it like this. Now this carbon is surrounded by 4 hydrogen atoms like this. So this is the central atom. In the valence shell of the central atom, how many bond pairs are there? 4 bond pairs are there. Nothing but you can write 4 sigma bonds also. Okay. This is one type of the molecule. Means there are different types of molecules are there. The molecule may contain only bond pair, or the molecule may contain bond pair as well as lone pair of electron. So the next example I will take is ammonia molecule here. In this ammonia molecule, which is the central atom? Nitrogen is the central atom. So since this nitrogen belongs to group 15, it is having 5 valence electrons. Out of 5 valence electrons, 3 valence electrons are utilized for the bond formation with 3 surrounding hydrogen atom. 2 electrons are left as it is. So these 2 electrons are not involved in the bonding, so that these 2 electrons are taken as what? Lone pair of electrons, and these are also called as non-bonding pair of the electron. So in this molecule, in the valence shell of the central atom, how many bond pairs are there? 3 bond pairs are there and 1 lone pair is there. Total number of electron pairs is 3 bond pair plus 1 lone pair of electron. This is how you have to calculate total number of bond pairs and lone pair of electrons present in the molecule. So now I will write here, this is the nitrogen atom, which is surrounded by 3 hydrogen atoms connected by a single sigma bond, and 1 lone pair of electrons are present on the nitrogen atom as it is. So you can take another example here. Water molecule I will take. In this water molecule, oxygen is the central atom, which is having 6 valence electrons. Since it belongs to group 16, 6 valence electron must be there. Out of 6 valence electron, 2 electrons are utilized for the bond formation with hydrogen. Remaining 4 electrons, these 2 electrons, 1 lone pair, these 2 electrons, 1 lone pair. This is also lone pair and lone pair. In total, how many electron pairs are there here? It is having 2 bond pairs plus 2 lone pair of electrons in the oxygen. That's why I can write the shape of the water molecule like this. In this one, 2 lone pair of electrons are there on the oxygen atom, and it is having 2 bond pair of electrons with the 2 hydrogen atom. So this is how you have to calculate the bond pair and lone pair of electrons present in the molecule. First thing, you identify the central atom, then go for the number of valence electron in the central atom, then utilize those electrons for the bond formation with the surrounding atom. How many are left unbonded or non-bonded situation, those are taken as what? Lone pair of electron. This is how you can calculate total number of bond pair and lone pair of electrons. The next thing is, here you can observe here, next point, these lone pair of electrons, since these are not involved in any bonding, they will occupy maximum space around the nitrogen. Whereas in case of bond pair of electrons which are shared between the nitrogen and hydrogen, they are occupying a minimum space around the nitrogen atom. That's why lone pair of electrons occupy maximum space around the nitrogen atom, and these bond pair of electrons are occupying minimum space around the central atom, you can say. Here also same thing, these lone pair of electrons are occupying maximum space around the nitrogen atom since they are not involved in any bonding, but these bonded pair of electrons are occupying minimum space around the nitrogen. The next point around this, in this one is, these lone pair of electrons and these are bonded pair of electron. Bond pair of electron is nothing but the electrons which are present in the bond. One bond means how many electrons? 2 electrons are there. This is also electron density and this also electron density. These electron pairs, they are being negatively charged, they will repel one another. That's why here lone pair of electrons also negatively charged and this also negatively charged. These electron pairs being negatively charged, they will experience some repulsive force between them, and that's why they try to move away from each other and they will occupy such a position in the space that minimizes the repulsion between them. That minimizes the repulsion between them here. Okay. Now this here is also there is a repulsion between lone pair and bond pair of electrons. If you go for this water molecule, in case of water molecule, here also same thing, these two lone pair of electrons, they are occupying maximum space. That's why the repulsion between the lone pair and lone pair of electrons is maximum here. And then if you go for bond pair and bond pair, since these are also negatively charged, they will repel each other. The repulsion between the bond pair and bond pair is minimum since they are occupying minimum space, and the lone pair is maximum. Then the repulsion between the lone pair and bond pair of electrons is in between what? Lone pair and bond pair. So the repulsive interaction is what? Lone pair of electron repulsion is maximum as compared to lone pair and bond pair of electrons as compared to bond pair and bond pair of electrons. That's why these lone pair of electrons occupy maximum space around the central atom, whereas bond pair of electrons are occupying minimum space around the central atom. These electron pairs being negatively charged, they will repel each other and they occupy such a position that minimizes the repulsion between them. The next very important point is, in this one, the multiple bonds are treated as single bonds. That is, for just for simplicity, we are considering multiple bonds as the single bonds. That means the shape of the molecule depends only on what? Sigma bond. 5 bonds will not decide the shape of the molecule. Just they are present along with a sigma bond. You don't worry about the 5 bonds. Only the shape of the molecule depends on what? Sigma bonds. Okay. These are the important points you have to keep in mind according to what? VSEPR theory. Then we will discuss what is the difference between the geometry of molecule, what is the shape of the molecule. Okay. Now, what is the difference between the geometry of molecule and shape of the molecule? Geometry of the molecule is arrangement of bond pair plus lone pair of electrons. Arrangement of bond pair plus lone pair is taken as what? Geometry of the molecule, whereas the shape of the molecule is only the arrangement of bond pairs. Only the arrangement of bond pairs is taken as shape of the molecule. If you take both bond pair and lone pair, that become as geometry of the molecule. This is very important point. You keep in mind, the shape of the molecule is only the arrangement of bond pair of electrons. Okay. Then in this one, in the shape of the molecule, there are two types. One we call it as regular shape molecule and another is irregular shape of the molecule. Regular shape molecule is the molecule which is having only bond pair of electrons and surrounded by same kind of the atom. Then only it is called as what? Regular shape molecule. For example, I will take CH4 molecule. In case of CH4 molecule, this carbon atom is surrounded by only bond pair of electrons and similar kinds of atoms, that is hydrogen. So that this molecule is considered as what? A regular shape molecule. Another example I will take here. In this one, if I take CH3Cl, this carbon atom is surrounded by 3 hydrogen atoms, and the fourth atom I will change it as what? Chlorine. Even though this molecule is having only bond pair of electron, it is not coming under regular shape because the surrounding atoms are not same. That's why it will come under what? Irregular shape molecule. Regular shape molecule is only the arrangement of bond pairs, and the central atom must be surrounded by same kinds of the atom. And the relation between the regular shape molecule and the dipole moment is, if the molecule is having a regular shape, you can say that directly the dipole moment of the molecule which is of regular shape will be equal to 0. Similarly, if you go for irregular shape molecule, the molecule which are having bond pair of electron as well as lone pair of electrons are called as irregular shape molecule. For example, already we have written one example here. In S3 already we have discussed this example. This nitrogen is having one lone pair of electron and which is surrounded by 3 hydrogen atom with the sigma bond. So that this molecule is having bond pair of electron as well as lone pair of electron. If any molecule is having bond pair and lone pair of electron, then it is called as what? Irregular shape molecule. For irregular shape molecule, the dipole moment will not be equal to 0. So that in 4 options, if they give a 4 different set of molecules, for which of the following molecule dipole moment will be 0, if you know which molecule is regular shape and irregular shape, directly you can tell what dipole moment will be equal to 0 or will not be equal to 0. This is what the main difference between regular shape molecule and irregular shape molecule. In some book they are given this is a symmetrical molecule and unsymmetrical molecule also, you can use this one. So the difference between the geometry and shape, and in shape you can call it as regular, irregular or symmetrical or unsymmetrical molecules. Okay. Now based on the total number of bond pair and lone pair of electron, there are different types of molecules are there, that are AB2 type of molecule, AB3, AB4, AB5 and AB6. These are the main types of the molecule. In this one different variations also there, we will discuss one by one. First I will go for AB2 type of the molecule. Now AB2 type of the molecule, any molecule having 2 bond pairs, that is of AB2 type of the molecule. Bond pairs directly I will take it as what? Sigma bond. Bond pair is nothing but sigma bond here. 2 sigma bonds. Any molecule is having 2 sigma bond, then the shape of the molecule will be linear. For example, if I take this is one bond pair and this is another bond pair, these two are being negatively charged, they will repel each other. Suppose in a molecule 2 bond pairs are there, if I place them like this, what happens? The repulsion between them, as they start experiencing repulsion between them, they start moving away from each other like this, and they try to occupy such a position where the repulsion between them is minimum. This is the ideal arrangement between the 2 bonds where they can experience minimum repulsion, because again if you start moving like this, again they can experience repulsive interaction. That's why this is the ideal arrangement of 2 bonds. Any molecule is having 2 bonds, they must be arranged in the linear fashion. That's why here in case of AB2 type of the molecule, A indicates the central atom, B is the surrounding atom. So that here A atom is connected to the 2 B atoms with the linear fashion. Only 2 sigma bonds are there. The angle between them is 180 degree and the shape of the molecule is linear. So now already we know how to calculate the total number of bond pair and lone pair of electron. Any molecule is given to you, just go for the central atom, write the number of valence electron and find out the number of bond pair and lone pair of electrons, and you will come to know if any molecule is having 2 bond pair, directly it is what? Linear shape. For example, I will take BeCl2. In this one, which is the central atom here? Beryllium is the central atom. So this belongs to group 2, means it is having 2 valence electron like this, and here 2 valence electrons. Each chlorine forms 1 bond with the beryllium, so that these 2 valence electrons are utilized. How many bond pairs are there here? This is having 2 bond pairs and no lone pair of electrons. 2 bond pair is nothing but what here? 2 sigma bonds. So that this molecule is having 2 sigma bond, means again the shape of the molecule is what? Linear only. This beryllium is connected to the 2 chlorine atom in the linear fashion, where the bond angle is again 180 degree and the shape of the molecule is what? Linear. One more point here, bond angle is angle between the 2 bonds is called as what? Bond angle. The angle between the lone pair and bond pair is not taken as the bond angle, and here the angle between the 2 bonds is what? 180 degree. Another example we will take here. If I take CO2 molecule, already we have discussed that multiple bonds are not considered in the shape of the molecule, or we can say that multiple bonds are treated as the single bond. In the CO2 molecule, which is the central atom here, carbon is the central atom. How many valence electrons are there in the carbon? 4 valence electrons are there. But here you concentrate on the surrounding atom. Surrounding atom is what? Surrounding atom is what here? 2 oxygen atoms are there. Each oxygen atom forms a double bond with the carbon. That's why here in this case you have to utilize 2 electrons of the carbon to form a double bond with oxygen. Again you utilize 2 electrons, again you form a double bond. Out of the double bond, already we know that one will be sigma bond and one will be phi bond, one will be sigma bond and one will be phi bond here. So this molecule, how many sigma bonds are there? 2 sigma bond. 2 sigma bond means what is the shape of the molecule? Again it is the linear. You can write the structure of CO2 like this. This is a C double bond O and again C double bond O. This is like this. This is the sigma bond and this is the sigma bond. 5 bonds are just, they are present along with the sigma bond. You don't worry about these 5 bonds, they will not decide the shape of the molecule. So again, what is the shape of this CO2 molecule here? Linear shape. So this is what AB2 type of the molecule. Okay, next we will go for AB3 type of the molecule. Now the next type of the molecule is, if the total number of bond pair and the lone pair of electrons will be equal to 3, then there are 2 possibilities are there, AB3 type of the molecule and AB2A type of the molecule. In AB3 type of the molecule, this molecule is having 3 sigma bond. If any molecule is having a 3 sigma bond, then the shape of the molecule is what? Trigonal planar, where A is the central atom occupying the center of this triangle and these surrounding atoms, they are occupying the corner of the trigonal here. So the shape of the molecule is what? Trigonal planar, and the angle between these 2 bonds is 120 degree here. This is like this here. This is the, I will take like this, and these 3 are the arrangement of bond pairs. This is the arrangement of bond pairs here. This is the central atom and these 3 are the surrounding atoms, so that they are arranged in the planar triangular manner, and the angle between these 2 bonds is what? 120 degree here. This is what the shape of the molecule. Hence this molecule will be what? Planar here. That's why it is triangular planar. Any molecule having 3 sigma bond, the shape of the molecule is trigonal planar, you can call it as, and in short we call it as TGP, trigonal planar shape here. For this type of example, I'll write BF3. Any molecule is given to you. How to calculate the bond pair and lone pair of electron? Identify the central atom here. Central atom is what? Boron. Boron belongs to group 3. So that the number of valence electron will be what? 3 here. Each fluorine forms how many bond here? 1 bond with the boron atom. That's why how many sigma bonds are formed here? 3 sigma bond. If the molecule is having 3 sigma bond, then what is the shape of the molecule? Trigonal planar. I will write it like this here. This is the boron and this is your fluorine atom and this is another fluorine and this is another fluorine. These 3 fluorine atoms, they are arranged in a triangular fashion around the boron atom, and here the bond angle will be again 120 degree. The shape of the molecule is TGP, like this. Or else you can write another example here. I will take SO3 molecule. What is the central atom here? Sulfur. How many valence electrons are there in the sulfur? 6 valence electron. Each oxygen forms a double bond or single bond? It forms a double bond. That's why you have to utilize 2 electrons for the bond formation with 1 oxygen, and here 2 electrons for another oxygen, and these 2 electrons for the another oxygen. Already we know that in a double bond, one will be sigma bond and another will be phi. Again sigma and phi. This will be sigma and another phi. In total, how many sigma bonds are there? 3 sigma bond. 3 sigma bond means again what is the shape of the molecule? Again it is what? Triangular planar only. So I can write the shape of the molecule like this. This is the sulfur with a double bond oxygen, and this is the double bond oxygen, and again this is what? Double bond oxygen, and here the bond angle is 120 degree. So these are arranged in the triangular fashion like this. Okay, already we have discussed that multiple bonds are treated as a single bond to predict the shape of the molecule. This is about AB3 type of the molecule. Next, AB2E is what? Here also 3 electron pairs are there. Out of that, two bond pairs are there and one will be lone pair of electron. Simply what we have done is, out of these three bond pair of electron, one sigma bond has been replaced by what? Lone pair of electron. Again these two are same. Arrangement of electron pairs is again trigonal planar only. Just one sigma bond has been replaced by what? Lone pair of electron. That's why again the arrangement of electron pairs is triangular only. And what is the shape of the molecule now? Shape of the molecule is only the arrangement of bond pairs. How bond pairs are arranged here? Like this. So that this we call it as angular shape, or we call it as V shape, or we call it as bent shape. So the shape of the molecule is what? V shape or bent shape or angular shape if the molecule is having two sigma bond and one lone pair of electrons. So these are the two variations coming under what? 3 electron pair system. Example for this one I will write it as, we can quote an example of SO2 molecule. SO2 is what? Again the central atom is sulfur here, and how many valence electrons are there? 6 valence electron. Out of 6 valence electron, 4 electrons are utilized for the bond formation with 2 oxygen, and remaining 2 electrons are taken as lone pair of electron. Out of this one will be sigma bond, then another is phi bond, sigma bond, and another is phi bond. How many sigma bonds are there? 2 sigma bond, and next one is what? Lone pair of electron. That's why this molecule is having 2 sigma bond and 1 lone pair of electron. The shape of this molecule is what? Again V shape or bent shape. You can write like this. This is the lone pair of electron as it is, and you can write a double bond with oxygen, and this is the double bond with the oxygen. And another point you have to concentrate here, due to increased repulsion among this lone pair of electron and the bond pair of electron, here the bond angle is what? Less than 120. Here also the bond angle will be less than 120. And what is the shape of the molecule here? Again it is a V shape or bent shape, because 2 sigma bonds are arranged like this. Shape of the molecule is only the arrangement of bond pairs. So this is the total number of bond pair lone pair will be equal to 3, this type of the molecules. Next type of the molecule we will go for A-before type of the molecule, where the total number of bond pair and lone pair of electrons will be equal to 4 here. Now the next type of the molecule is total number of bond pair plus lone pair of electron will be equal to 4, then it is called as 4 electron pair systems. In this one there are 3 variations are there, that is A-before, the molecule may have 4 sigma bond. AB3E, the molecule may have 3 sigma bond and 1 lone pair of electron. Means out of 4 sigma bond, 1 sigma bond has been replaced by what? 1 lone pair of electron. Similarly here again 1 sigma bond has been replaced by 1 lone pair of electron, so that it becomes as AB2E2 type of the molecule, where the molecule may have 2 sigma bond and 2 lone pair of electron. So that you keep in mind, whenever 4 electron pair system is there, there are 3 possibilities. The molecule may have 4 sigma bond, or it may have 3 sigma bond and 1 lone pair of electron, or it may have 2 sigma bond and 2 lone pair of electrons. The first possibility is, if the molecule is having 4 sigma bond, then it is what? A-before type of the molecule, where the central atom A is surrounded by 4 different atoms or same kinds of atom here, but it is having what? Bond pairs. All the 4 bond pair must be there. If the molecule is having 4 sigma bonds, then the shape of the molecule is tetrahedral here. Already we know that if the molecule is having 3 sigma bonds like this, I'll try to show you how it is. And if the molecule is having 3 sigma bond, already we know that this is having a planar arrangement of 3 sigma bonds. Whenever 4th bond is introduced like this, whenever the 4th bond is introduced like this bond pair will offer repulsion to the remaining bond pairs, so that these 3 bond pairs are slightly moving down, and then you will get a 3-dimensional tetrahedral shape. This is the tetrahedral shape of the molecule. So any molecule is having 4 sigma bond, then the shape of the molecule will be what? Tetrahedral. Next possibility is, out of 4 sigma bond, 1 sigma bond has been replaced by what? Lone pair of electron. Suppose you assume that here lone pair of electron is there, then how many bond pairs are present in this molecule? 3 bond pairs only, and these 3 bond pairs are arranged like this. What is the shape of the molecule? This is called as pyramidal shape, because the shape of the molecule is only the arrangement of bond pairs. That's why here one sigma bond has been replaced by what? Lone pair of electron. Remaining 3 sigma bonds are arranged like this, so that the shape of the molecule will be pyramidal. Another thing is, due to increased repulsion among lone pair and bond pair of electrons, again these 3 bonds are slightly moving inward, so that again bond angle decreases from what? 109 to 107. Here 109 is what? Perfect tetrahedral angle, and due to increased repulsion among lone pair and bond pair of electrons, bond angle is decreasing to 107. Another possibility is what here? 2 sigma bond and 2 lone pair of electron. Another bond pair has been replaced by what? Lone pair of electron. Only 2 bond pairs are left, and they are arranged in the V shape here. That's why the shape of the molecule is what? V shape. What is the geometry of the molecule? Tetrahedral. Because it is a 4 electron pair system, means all the electron pair must be arranged in the tetrahedral fashion only. This is the tetrahedral fashion only. You have to arrange the all electron pairs. But the shape of the molecule is what? Only the arrangement of bond pairs, and here you have to take 2 bond pairs, so that the shape of the molecule is V shape or bent shape or angular shape. You can take care. Now we will write example for each type of the molecule. First one, I will write another example here, NH4 plus. Always you keep in mind, if you calculate the total number of bond pair and lone pair of electron, and based on this hint you can predict the shape of the molecule. So any molecule is having 4 sigma bond, then the shape of the molecule is what? Tetrahedral. Here if I write an example of NH4 plus, suppose positively charged species and negatively charged species are given. Any positive charge is there, you remove 1 electron. Any negative charge is there, you have to add 1 extra electron. Here I will tell you how to do this one. Nitrogen is the central atom here, so that how many valence electrons are there in the nitrogen? 5 valence electron. Since this is having 1 positive charge, you have to remove 1 electron here. So how many hydrogens are there? 4 hydrogen atoms. Each hydrogen atom is forming 1 sigma bond. In total, how many sigma bonds are there in this molecule? 4 sigma bond. Hence the shape of the NH4 plus is what? Again it is tetrahedral. Suppose if I write SiF4, silicon tetrafluoride is there. In this one, silicon belongs to again group 14. How many valence electrons are there in the silicon? Again 4 valence electron. Each fluorine forms 1 sigma bond with the silicon. In total again 4 sigma bond. The shape of the molecule is again tetrahedral. You will get like this. Next thing is what? AB3E type of the molecule, where 3 sigma bond and 1 lone pair of electron is there. Very well known example for this one is, again you will write NH3. In this NH3, the number of valence electron will be how much here? 5 valence electrons are there, and here 3 hydrogens are utilized for what? Bond formation. Remaining 2 electrons are taken as lone pair of electron. This is having a 3 sigma bond and 1 lone pair of electron. That's why the shape of the ammonia molecule must be pyramidal. Next example here, already we have taken H2O molecule. In this one, the central atom is oxygen, where this oxygen is having 6 valence electron. 1, 2, 3, 4, 5 and 6 valence electrons are there. Out of 6 valence electron, only 2 electrons are utilized for the bond formation with 2 hydrogen atom. Remaining 4 electrons are 2 lone pair of electron like this. This is 1 lone pair and this is 1 lone pair. So that this molecule is having what? 2 sigma bond plus 2 lone pair of electron. What is the shape of the molecule then? V shape. This is what? 4 electron pair system it is. There are 3 possibilities. Next type of the molecule is, if the total number of bond pair and lone pair of electron will be equal to 5, then what are the possibilities? We will see it now. Now, if the total number of bond pair and lone pair of electron will be equal to 5, then it is called as 5 electron pair system. In this one, 4 possibilities are there: AB5, AB4E, AB3E2 and AB2E3 it is. The first type of the molecule is AB5. If the molecule is having 5 sigma bond, all the electron pairs are bond pair, then we call it as what? The molecule is having 5 sigma bond. If the molecule is having 5 sigma bond, then the shape of the molecule is trigonal bipyramidal. Already we know that if the molecule is having 3 sigma bond, the 3 sigma bonds are arranged in what? Trigonal planar shape. Next here extra 2 bonds are there. One bond will be above the plane and another will be what? Below the plane. So that above one pyramid is formed and below one pyramid is formed. That's why it is called as trigonal bipyramidal shape here. And the bonds which are present in the triangular plane, in the triangular plane 3 bonds are there. Those bonds which are present in the triangular plane, those are called as what? Equatorial bonds. And the bond which is present above and below the plane, those are called as what? Axial bonds here. This is very, very important, and the angle between the two equatorial bonds will be what? 120 degree. And these axial bonds are exactly perpendicular to the triangular plane. So any molecule is having 5 sigma bond, then the shape of the molecule will be what? Trigonal bipyramidal. The next type is A-B4E. In this one, what I will do, just one sigma bond will be replaced by lone pair of electron. Next possibility is just you go on changing the number of sigma bond with number of lone pair of electrons here. If you see here, these two molecules, these two are almost same, where this sigma bond has been replaced by what? Lone pair of electron. Then the shape of the molecule will be different, because the shape of the molecule will be what? Only the arrangement of bond pair of electron. That's why if the molecule is having 4 sigma bond and 1 lone pair of electron, then the shape of the molecule will be what? Seesaw shape. One point very, very important you have to remember here, that is, you should not touch these axial bonds for replacing the sigma bond with lone pair of electron. Axial bonds are never replaced by lone pair of electrons. Only equatorial bonds must be replaced by lone pair of electron for the next possibility, because if you replace these sigma bond with these axial bonds with the lone pair of electron, then the repulsion will be maximum. That's why only the equatorial bonds are replaced by lone pair of electron. That's why the first possibility what I am doing is, this sigma bond has been replaced by what? Lone pair of electron. So the shape of the molecule will be seesaw. Any molecule is having 4 sigma bond and 1 lone pair of electron, the shape will be seesaw shape. Next possibility is, we will replace 2 sigma bond with a lone pair of electron, and the remaining 3 sigma bond will keep as it is. Now what happens? 2 lone pair of electrons are introduced in the equatorial bond. Now what happens here? Equatorial plane, in this one 2 lone pair of electrons are introduced here, so that 2 sigma bonds are removed and 2 lone pair of electrons are added here. Then what happens? What is the shape of the molecule? Shape of the molecule is only the arrangement of bond pairs. If you see here, this exactly looks like a T here. That's why the shape of the molecule will be T shape. Any molecule is having 3 sigma bond and 2 lone pair of electron, then the shape of the molecule will be T shape. Any molecule is having 3 sigma bond and 2 lone pair of electron, then the shape of the molecule will be T shape, because in the equatorial plane you are placing 2 lone pair of electron, so that these 2 lone pair of electrons are not considered in the shape of the molecule. Shape of the molecule is what? Only the arrangement of bond pair of electron. One will be above, another will be below, and this is the equatorial bond, so that the shape of the molecule will be T shape. The next possibility is what? All the 3 sigma bonds which are present in the this equatorial plane, they are replaced by what? Lone pair of electron. That's why this is the next possibility. If all the 3 sigma bonds are replaced by what? Lone pair of electron, only 2 axial bonds are remaining. Again the shape of the molecule will be what? Arrangement of bond pairs. That's why here these 2 bond pairs are arranged in the linear fashion. That's why the molecule which is having 2 sigma bond and 3 lone pair of electron, again it is having what? Linear shape. That's why all these are the different possibilities when the total number of bond pair and lone pair of electrons will be equal to 5. So now we will write an example for each type of the model. First you have to remember 5 sigma bond is trigonal bipyramidal, 4 sigma bond plus 1 lone pair is seesaw shape, then 3 sigma bond and plus 2 lone pair of electron is T shape, then 2 sigma bond and 3 lone pair of electron is linear shape. Now we will write different example for these things. First one I will write for TBP. One example I will write PCl5 is a very, very well known example for this one. Phosphorus is the central atom here. How many valence electrons in the phosphorus? Since it belongs to group 15, 5 valence electrons are there. That's why each chlorine forms 1 bond with the phosphorus. Total how many sigma bonds are formed here? 5 sigma bonds, and no electrons are left as lone pair of electron. That's why only 5 sigma bond, then the shape of the molecule will be what? Again it is trigonal bipyramidal. This is one thing. Next is what? A-B4E type of the molecule. For this one we will write another example, SEF4 I will write. So the central atom will be what here? Sulfur. What are the number of valence electrons here? 6 valence electron. You have to write all the 6 valence electrons like this here. Out of the 6 valence electron, 4 valence electrons are utilized for the bond formation with the fluorine. Next, these 2 electrons are which are not involved in the bonding, they are taken as what? Lone pair of electron. If you see here, this molecule is having 4 sigma bond and 1 lone pair of electron. Then what is the shape of the molecule here? Seesaw shape. Next example we will write for T shape of the molecule. Example we will write ClF3. where the chlorine is the central atom. How many valence electrons in the chlorine? Since it belongs to halogen group, it must have 7 valence electron. Out of 7 valence electron, each fluorine utilizes 1 electron, so that 3 sigma bonds are formed. Remaining 4 electrons are taken as what? 2 lone pair of electrons. This is 1 lone pair and this is 1 lone pair. The total number of sigma bond is 3 and 2 lone pair of electrons are there. That's why any molecule with 3 sigma bond and 2 lone pair, what is the shape of the molecule here? Again, it is a T shape. Next example is very important. Here I will write XeF2. What is the XeF2 here? Xenon, which belongs to noble gas. So that the number of valence electrons in the xenon is how many here? 1, 2, 3, 4, 5, 6, 7, 8 valence electrons are there in the xenon. Out of 8 valence electrons, fluorine utilizes 2 valence electron. Remaining 6 electrons are taken as what? 3 lone pair of electron. This is lone pair, this is lone pair, and this is also lone pair. That's why this XeF2 is having what? Here 2 sigma bond plus 3 lone pair of electron. Any molecule with 2 sigma bond and 3 lone pair of electron, what is the shape of the molecule here? Linear. That's why XeF2 is also having linear shape. So this is how you can calculate the total number of bond pair and lone pair of electron, and you can compare them to these type of the model, and you can predict the shape of the molecule. The last type of the molecule is AB6 type of the molecule. Then you will come to know all the type of the molecules. Now the last type of the molecule is, if the total number of bond pair and lone pair of electron will be equal to 6, then it is called as 6 electron pair system. In this one, there are 3 possibilities are there: AB6, AB5E and AB4, E2. Already we know that E represents the lone pair of electron. Here E2 means 2 lone pair of electron. E1 means what it is? 1 lone pair of electron. B6 means what it is? B represents the surrounding atom. So that there are 3 possibilities. First one is, if the molecule is having 6 sigma bonds, then what is the shape of the molecule? If the molecule is having 6 sigma bond, out of the 6 sigma bond, 4 sigma bonds are arranged in the square plane like this. All the 4 sigma bonds are present in the plane, and the 5th sigma bond is above this plane and 6th will be below this plane. That's why here these 4 bonds are present in the square plane, and this bond is above the plane and this bond is below the plane. Such type of the molecule are said to have what? Octahedral shape. Then the shape of the molecule will be octahedral. If you join the corner of these molecule like this, then you will get an octahedral like this. So the shape of the molecule will be what? We call it as octahedral. This is the octahedral shape here. That's why any molecule is having a 6 sigma bond. Out of that 6 sigma bond, 4 sigma bond will be arranged in the square plane, and one will be above the plane and another will be below the plane. That type of the molecule is octahedral shape here. Then the next possibility is, just you have to replace this above bond and below bond with the lone pair of electron. Here the bond below the plane I have replaced with what? Lone pair of electron. In this case of total number of electrons 6, what you have to do is, you should not replace these planar bonds with the lone pair of electron. Only the bond which is above and below the plane is replaced with what? Lone pair of electron, so that the bonds which are present in the square plane, they are never replaced by the lone pair of electron. If you do so, then the repulsion will be maximum. That's why just we are replacing the bond which is present above and below with the lone pair of electron. That's why simply what I have done, these two are almost same. This below bond is replaced for what? Lone pair of electron. Again we know that the shape of the molecule is what? Again that is only the arrangement of bond pairs here. That's why this type of molecule is having what? Square pyramidal, because these lone pair of electrons are not considered in the shape of the molecule. Here you will get a pyramid above this plane like this here. This is called as square pyramidal. That's why any molecule is having 5 sigma bond and 1 lone pair of electron, then the shape of the molecule will be what? Square pyramidal. The next possibility is, this bond is also replaced by what? Lone pair of electron. That's why this above and below bonds are replaced by the lone pair of electron, and remaining 4 bond pairs which are present in the square plane, they are as it is. Then the shape of the molecule will be what? Square planar, because these two are not considered in the shape of the molecule. So in this one there are 3 possibilities. AB6 is octahedral, AB5E 5 sigma bond and 1 lone pair will be square pyramidal, and 6 sigma bond, sorry, here you have to write 4 sigma bond. 4 sigma bond and 2 lone pair of electron, then what you have to do? Square planar molecule. Now we will write different example for this one. For first type of the molecule, I will write an example of SEF6 here. 1, 2, 3, 4, 5, 6 valence electrons are there in the sulfur. Each fluorine is forming 1 bond with the sulfur here. So that how many sigma bonds are formed in total here? 6 sigma bond. So any molecule is having 6 sigma bond, then the shape of the molecule will be what? Octahedral. For this type of the molecule, we will write another example here. ClF5 we will take here. So that chlorine is the central atom which is having 7 valence electrons like this. So out of the 7 valence electron, 5 electrons are utilized for the bond formation with the fluorine. So that how many sigma bonds are formed here? In total 5 sigma bonds, and these 2 electrons are taken as lone pair of electrons. So this molecule is having 5 sigma bond and 1 lone pair of electron. Hence the shape of the molecule will be what? Square pyramidal. And the next one is, we will write Xenon Tetrafluoride. In this one, xenon is the noble gas which is having 8 valence electron. 1, 2, 3, 4, 5, 6, 7 and 8 valence electrons are there. Out of that, 4 electrons are utilized for the bond formation with 4 fluorine atoms. So that here 4 sigma bonds are formed. Remaining 4 electrons, we will take it as what? Lone pair of electron. That's why it is having 4 sigma bond and 2 lone pair of electron. Then the shape of the molecule will be square planar. These are the different types of the molecules which comes under VSEPR theory, and then this completes all type of the molecules from AB2, AB3, AB4, AB5, AB6, and in that one, in each model we have discussed different variations here. Thank you for watching video till end. For more shortcuts and tricks, subscribe to the Effortless Chemistry channel. Thank you very much.